Hey guys, Shane here, Fugatech 3D Printing. Today is going to be part 2 of my Hypercube build, and we're going to install all of the Z and most of the X and Y parts into the frame. Okay, welcome back guys. Thanks for joining me. I know everyone's real excited about this part 2, so let's get right to it. I'm going to go over some of the parts that I'm using, some of the parts that I've modified, even though I said I wasn't going to do it. So I modified a few of the parts, and then we're going to go over all of the Z first. We'll come back, and then we'll go over all of the X and Y, and we'll get all those installed. All right, so here we have the parts right here. These are going to be all the parts I need for the Z. And there's a few decisions that I had to make when I was getting ready to build this. And the first off was, am I going to use the stock Z side plates, I guess, for the actual ZX to slide up and down. These mount right here to the side of the printer. And as you can see, there's only 2 bolts right here that actually lock into it. So there would be a little bit of wiggle. It's fairly strong, but I thought I could do better. So I did find one that was similar to this bracket here, but it was actually an L. So it came down, and this part was down here, and it was like this. I didn't like that because, again, it would have a lever point down here at the bottom. I wanted this to be a T. So I went ahead and a little bit of help from my friend Kyle. He helped me modify this to put it right here through the middle. So having 3 points, this thing is not going to move, and it's centered to the frame. So this will end up mounting in right in here. And we'll have those 3 T-nuts locking that in, and that will just, and it'll line up right with that. But yeah, it'll just lock in and be absolutely perfect. It'll make the Z rock solid when it comes to the linear rails. So here I have one completely assembled. I did modify it to make one bracket to be 20 millimeters. This one is 10 millimeters. There was no real advantage whether having it being 10 or 20. So I'm just gonna make 120, 110 just because I have that printed, and here are some of the other parts here that I made. And the other thing I did was I made this part with captive nuts. So you can see here the nuts are stuck in there, so I can tighten this down all day long. These will not move because it's PET G, and it slides with it. It's a little loud, as you can hear. I would love to go with some Durlin nuts or Drylin nuts, or I should say Drylin bearings, but I'm not going to do that right yet. We're going to stick with this. Obviously, it's not going to be moving that fast, it won't be that loud, but anyways, that's where we're going to start for there. Here I have, this is the top plate for the lead screw and the bearing that goes in there. This is the mount for the lead screw nut that will attach to the Z-axis right here on the back like so. So I have that already. And then this is the motor mount for down at the bottom of the actual frame. So these are the actual mounts for the smooth rods. These will actually hold it on. There'll be 2 T-nuts going to each one of these to make sure that's locked in nice and tight. And then we have here 2 options for your Z-axis. So the first option here is a 400 millimeter lead screw that is attached to the motor itself with your TA nut. Your other option here is to add a 400 millimeter lead screw onto a coupling and then the motor there. Now when you do this, you lose Z height because you lose about 40 to 50 millimeters right here just because of the coupling. So what I think I'm going to do is I think I'm going to go with this. The rod seems to be fairly straight. I haven't noticed any variances in it rolling it along. It's a little hard to tell with when it's attached. It's easier to take this off. You can roll it along, see if there's any variances in it. But this seems to be pretty straight. I think I'm going to go with this because I'm going to maximize my Z height and not have to worry about getting the coupling in the way, and it'll be much more solid. And then I may or may not use this piece to lock it in, because sometimes if there is any variances, your lead screw, you will have Z wobble because you're locking the top of it still. If you were to take this off and let it flow freely, your Z wobble goes away. So we'll see how that goes. And then, the one last part here is anti-backlash. I am not a huge fan of anti-backlash nuts, but I figure I might as well put one in here because it should supposedly help with this build more. So I have this basic version right here that has the spring and the 2 parts that you thread on, and you get it right about here, and that just eliminates any backlash I should say. But then I have this Drylin anti-backlash that actually just screws right on. There's 0 movement in this whatsoever once it's on there, which is quite impressive. So we'll actually see if I end up using this, and if you want to make it tighter, you just tighten or loosen this bolt, and it raises this arm, which increases the tension on your lead screw. I don't know which I'm going to use. I don't know if either one is actually even going to work. With the build, the way I have it set up right now, I might need to add a spacer onto here in order to make this work. So we're gonna build it straight up with this one first, see how it goes. If I end up not liking it and I want to use this one, I will create a very quick spacer in Fusion 360 if I can't find one in the modified files anyways. But I think this might be the way I end up going. This is also much quieter because there's no metal parts against it. It is this Dryland plastic, whatever this stuff is made of. It's awesome, but we might go with that. So without further ado, let's take a look at how we're going to get these all installed. And I did forget to specify that these are 8mm smooth rods, and these ones are 350 millimeters long. I just had to buy a 400mm one and then cut it down to size with a cutoff wheel on my Dremel, which took like 2-3 minutes to just get through this real quick. It wasn't a problem at all. If your ends are not perfect, that doesn't matter because you're not going all the way to the end anyways. It's going to be trapped inside one of these printed parts. So let me go get out the M5 bolts and the T-nuts, and we can start putting at least the Z-axis on here and get that going. Alright, so here is the Z carriage assembled. So I've got the lead screw mount here, and then for the guide rails, the smooth rods right here. I'm using 8mm for now. I do have 10mm here waiting, but I don't have the bearings, and these parts are not made for 10mm, so I would need to reprint these parts at a later date. But for now, I'm going to go ahead and try 10mm or 8mm and see how it turns out. Now I just need to add one more T-nut down here. So these are rectangles so that you can actually set the T-nut down in there straight and then put your screw in and then turn it, and then it will actually clamp. So that's how that's done. So I'm going to go ahead and finish this up and get it on here and then see how we line up with our smooth rods. Alright, so I had to do here is I had these corner brackets all the way up here to the end of the 2020 extrusion, which didn't line up any of the parts. So I had to move this cross beam down, almost 20mm in order to make the smooth rods line up with that. I think this is about right now. It's going to take a little bit of tweaking. It's a little hard to show this as I'm actually doing it, but I at least show you that you need to make sure that these 3 points are all in line, because these smooth rod holders and the for the Z motor are all lined up perfectly. So just gonna make sure you get those all lined up right. Okay, so here's the Z axis fully assembled. You can see here I had this actually, this one I had right, this one I had backwards. This actually had mounted underneath. It actually goes on top of your 2020. I'm using 2040. These here go on top as well. I think they might go underneath if you're using 2020, but again, for me, with 2040, I had to put these on top because down below was just too long. I would have had to have a longer lead screw and longer smooth rods. And coming up here, you see here we have the anti-backlash nut threaded in there together. So So if I move this, everything moves real nice. The new Z brackets here on the on the Z plate, everything works great on there. So what I had to do is I had to run this all the way down, make sure that these were where they should be, and then run it all the way back up to the top, and then attach these. Now these ones here go on the bottom. As you can see, they're there. I still need to put in the other set of T-nuts on here. Not a big deal. And then these are just using, I think they were 20 or 25 millimeter M3s with a nylock nut on them. I wish these were tapped for, you know, the screw captures, but they're not. The nut captures, I should say, it's not. So this is all lined up real nice and moving just beautifully. If I spin that, not a problem. Oh, and the other thing, because I'm using 2040, if you're using 2020, you could have your motor connection. So here's just a motor here. I could have had it like this, and it would have cleared the bottom of the 2020 extrusion. Because I have 2040, I had to turn it sideways like this, so my cable's coming out here. This is roughly where the board is going to go. I'm not fully certain on it yet, but it'll go roughly there. If I need to undo this, I can easily take this off, wind this, spin it, and reattach it. So 2 more T-nuts need to go here, 1 more in each one of these, and 1 more each up here, and then the Z will be complete. So I'm going to leave it at that right there. Like I said, I'll just put those in. The Z is done. Now let's take a look at the hardware that we need for the X and Y axis. All right, so now the Z is done, let's take a look at what we need for the X and Y. Now this isn't all the parts, but these are all the parts that I'm going to do today. I'm not going to worry about the motors or some of the other idler pulleys. I'm worried about just getting at least the rods up and what attaches to them on there. So for the Y, we're going to go ahead and be using 8mm steel rods, which I've cut down to length, and they are 300 millimeters in length. And then for the X, we're going to be using carbon fiber tube, and these are 10mm tubes. They are 10 by 8, so they have 2mm walls in them. They look to be really good in Tech 2C's video, so I figured I'd give them a try. All right, and on these carbon fiber rods, I'm going to be using these iGES bushings. So iGES was kind enough to help me out with this project, and they sent me these 10mm bushings, which go right on here, and they are just super duper slidey. They go great. I did have some brass ones that I was going to use for if I was going to use the 10mm or 8mm rod, like the solid rods, instead of using carbon fiber, because I can't get tubes. Tubes are too hard to get in metric for Americans. But I could find this carbon fiber tube on AliExpress. So I decided to go with that, and I decided to go with the iGES bushings. That way they'll slide easier and they won't mark up the laminated carbon fiber. So that should work out well. And they will actually go inside of these. These are the X tubes. They mount to the back of the extruder carriage, the X carriage, and 2 of them will slip inside. There's a tight fit, but 2 of them do fit inside. Yeah, and I'll do that, and I'll just smash 1 in one side, 1 in the other side, and then they will be good to go. And now these are the original X and Y. I should say these are the Y. So these are the original Y clamps for the 8mm steel rod. I personally find these to be like super duper not enough. So I did find these online, which are much heftier. I think these will do the job a lot better. They simply just go on there, and then you just attach it with 2 of the M5 T-nuts to the actual 2020 frame. And then here we have the original, this, I guess you call this the Y carriage, I guess, on a Core XY machine. And this gets a LM8UUU or LMMM88UU. This is basically the double long bearing, which just barely fits there. A little bit comes out the sides, but that's okay. But I was saying these are the original ones because these do not have the captive nut slots, where this version does. I think Arthur or someone made these, but I'll link all the parts down below so you guys can check them all out. But I will be using these. Those fit on there great, and they just have this little back plate that sits on there, and this clamps it to the 8mm rod, the smooth rod. And that should be all the parts. So I'm going to go ahead and throw this together real quick. Shouldn't take too long, and then I'll be able to at least have this part done, and then the next part will be motors and whatnot. Alright, so here I have the X and the carbon fiber rods, and I've got the bearings on there. And here we have the Ys. They are good to go. So the Ys are just going to go right in here. I'll need to just push these down a little bit more and then pop them back out. But they will just line up right underneath here for now. I don't know if that's going to be the final placement, but at least it'll get there in and installed. And then I'll put this in the middle, and then we can install the X after we get these ones installed. So one thing to remember when you're using the T-nuts, the twist lock T-nuts I should say, you need to make sure that they actually turn. So I'm always looking up underneath. These ones you got to go by feel because you can't see them, but once we're underneath you can at least see and make sure those are on there. If I pull that down, that is not going anywhere. Sweet. One down, one side to go. Alright, all we got to do now is put this in here and got to angle it as well as we did for those and just twist it, and now it is in line with that. Now all we got to do is put on the end caps, and this is assembled. I am pretty excited about this, not gonna lie. Alright, well, that is the Z, the X, and the Y all assembled on here, and I have to say, it looks great so far. These are a little bit loud, but I think over time, once it wears in a little bit, or maybe once we actually get some weight on it, it won't go as loud. Again, I do have some Aegis 8mm bearings that they're the dryland ones that I would love to use on here. Number one, I heard they wear a little bit, but number two, they don't fit in these carriages, so I would need to try and find out how to modify these. I'm not very good with circles in Fusion 360, and I can get this carriage in a Fusion file, but I really can't modify it, so I might need to reach out to one of my buddies for help, or maybe ask you guys for help eventually, but for now, we're just going to go with this. I want to do it almost as stock as I can for what Tech2C did, because I like the way he designed it. I want to see how his actually worked, and then see what do I want or what do I need to upgrade. A few things I wanted to upgrade already just because I could tell I didn't like them to begin with. But the rest of it, again, I'm trying to stay as true as I can to Tech2C's original design, or what his like updated design was in the end. I do need to put a shout out there to Aegis. Thank you so much for sending me the bearings. I have other things from Aegis which I will announce when we get to using them. But thank you guys for helping me out with this project. It really means a lot to me that you want to help out and show people that you can use things like that for 3D printers. So I'll put a link down below for the parts that I got from Aegis, along with all the other parts that I have here. All that will be down in the video description, so if you guys want to pick up any of these parts, you can. We're going to call that it for today, guys. Thank you for bearing with me. I know it's been a while since I did a video on this, but we're getting further now. So next we'll probably do the X carriage, and then we'll do the belt and motors. We'll do all that in the next video. So I'll get all those parts together, make sure I have everything, and then get that filmed as soon as I can. So again, thanks for watching, guys. Big thumbs up if you like the build. I appreciate it. If you want to help me out, down below, hit the subscribe button. Make sure you hit the bell icon. That way you get notification anytime I upload new content, especially when I upload the next part for the Hypercube if you want to follow along. If you want to support me with financially, Patreon link down below. Donate me $1 more. Current Patreons. Thank you guys for your support. All that money comes into paying for things like building the Hypercube. I just gave me some little parts, but all the rest is out of pocket for me. If you want to support me without spending your money, there's affiliate links down below. Go and update all your bookmarks with those. I appreciate it. And some other videos over here, so I can do the part 1 for the Hypercube and then some random video down below it. So thanks for watching, guys, and as always, happy printing.